Welcome to the video lesson on correlation coefficient. Correlation coefficient is a measure of how related two different variables are. And where we look at it is typically in a scatter plot. So we'll start this lesson talking about that. A scatter plot is a collection of ordered pairs, x and y. So that's a collection of points on a Cartesian graph. And the x and the y can represent two different variables. That's why this is a part of two variable statistics. So a scatter plot is itself just a collection of individual dots. But in a graph, the general trend or shape of those dots can give us information, and correlation coefficient is one of the ways that we talk about that information. So first of all, I'll talk a little bit about what a positive versus a negative correlation is. A positive correlation is one where as the x values increase, the y values increase as well. So as you're moving to the right, these dots are generally increasing in their height or their y coordinate. Another way of saying that is that the general trend of this data has a positive slope, because a positive slope is one where as a line increases in its x as you move to the right, it increases in its y, it moves up. So that's what we're saying here. In this case, as one goes up, the other goes up, they move up together, and the general trend of this line has a positive slope. This goes up, this goes up. In an example without a scatter plot, like in a table of values, we're following that same idea. It's that as the x values increase, the y values are generally increasing as well, even if one or two of them didn't increase. And in this case, from one to the next, they're all increasing. But even if one or two went down, if the general trend is that they increase, then that would have a positive correlation. A negative correlation is the exact opposite. As you increase in your x coordinate values, your y coordinate values decrease as a general trend, or the general trend of the data would have a negative slope. It's generally going downwards towards the right. That is a negative correlation. And again, in a non-scatter plot example, as your x coordinates increase, as my x values go up, my y values are going down. And even if one or two of them didn't, as the general trend decreases, shows that I have a negative correlation. And finally, it's also possible that a set of data that shows two different variables is not connected. Like this doesn't seem to be going up or down, or rather there are some points that could be going down and others that are going up. And that is where there's no discernible pattern of upwards or downwards trend. Those things are not correlated. So if you want to pause and try these to see if you think they are positive, negative, or not correlated at all, you can do that. And the ones that show any linear trend at all are this one, which has a negative, and this one, which has a positive. This one has a linear trend, although, so this one is a negative and this one's a positive correlation. These ones here are uncorrelated, and this one, even though it is a linear trend, would be an example of not being correlated, because as the x increases, y stays the same. It seems that x has no impact on y at all. So just to show you that example that we had done with a table of values, to turn that into a scatter plot, I think is pretty self-explanatory. You'd fit some scale that will fit all of your x values and find some scale for your y's that will fit all of those. And you're really just plotting points one at a time. And as you go through that process, you can tell as a general trend if that data is increasing, if it's linear. In this case, this data appears to be pretty linear and the trend is increasing. This would be a positively correlated set of data. I'll skip over this next example. But in addition to either being positive or negative, correlation can either be strong or weak. And that doesn't necessarily have to do with how steep the line is, but it does have to do with how clustered the data is. So these data points, which are closer together, they're closer to that middle trend line, as opposed to these, which are much more spread out. So a stronger clustering of points is a stronger correlation, and more spread out is weaker. And it doesn't matter if it's positive or negative. These two, if they're equally spread, are equally weak. And these two, if they're equally condensed, are equally strong. And if there's no trend, then there's no correlation at all. And those clusters, or how strong or how clustered together they are, can also be measured numerically. And a linear correlation coefficient, which is the measurement, the numerical value of how clustered together the data is, ranges from -1 and 1. So being equal to -1 or equal to +1 is a perfect correlation. And closer to 0 is weaker, and equal to 0 is no correlation at all. So these are just general guidelines, and we'll talk more about these in class, but being exactly equal to 1 or -1, whether it's positive or negative, is a perfect linear correlation. Being near positive or negative 0.87. So this is just an approximation. If you had 0.88 or 0.89 or 0.86, that would be considered strong too. Negative or positive 0.75 is considered moderate. Well, what if you had something between 0.75 and 0.87? Well, it would be something between moderate and strong. So you could say moderate / strong. And similarly, between 0.5 and 0.75 would be somewhere between moderate and weak. And two correlations that are positive and negative, if they have the exact same number, are considered to be the exact same strength. So just to show you what that looks like on a graph, the difference between strong, weak, moderate, and very strong or perfect negative correlations, this has a general trend downwards, but it is pretty spread out. And this really doesn't have any trend at all. The more there is a trend and the more clustered together the data, the stronger the correlation. And the same thing applies for a positive correlation. The more closely packed together or clustered the data is close to that line, the trend line, the stronger the correlation. So finally, how would one come up with these numbers? Like, I guess this is relatively weak and this is definitely weaker, so it makes sense that this number is closer to 0 than this one. But there is actually a method to estimate a correlation coefficient, and here's how it works. We'll use this formula where R, which is the letter for correlation coefficient, is equal to plus or minus, if it's a positive or negative slope, 1 minus the shorter length divided by the longer length of the rectangle that you draw around the data. So what you want to do is fit a rectangle around the data. When you're using a ruler, you'll just slide your ruler over to make it parallel, and you'll close off such that your line goes through the outermost point. It's okay if it touches it. In fact, it should pass through the center of it. You'll measure those side lengths and plug into the formula. You have to decide on your own if the correlation is positive or negative. So in this case, because it's going downwards, I know that it's negative, and that's it. I just plug into the 1 minus my shorter divided by my longer length, and that gives me my approximate correlation coefficient. And that is it.